Alright, in a way that's super not frustrating at all, my program stopped recording again. When I was almost done with this problem, I then went on to do 12, 13, 14, well, whatever. I did 12A, 12B, 12C, and I went on to do 13, and as I was getting to do 14 is when I realized the damn thing stopped. So I guess we're going back and at least talking about these again. I'm not going to go through them super hard, but I don't remember exactly how far through 11 I got. I definitely already did 11 by going across row 1, and I was just starting to talk about how it looks when you go across row 2. The big difference was this sign pattern. It was minus plus minus instead. Other than that, there's no huge difference, and of course we get the same answer of negative 18. Great, moving on. Number 12 is where we were finding the inverse of a 2 by 2. So I guess I talked about how this whole thing about if it exists is because if the determinant of a matrix is 0, then the matrix is referred to as non-invertible. It doesn't have an inverse. And that's obvious, really, because our formula for the inverse contains this 1 over the determinant scalar, right? And of course 1 over 0 is undefined. So of course you can't have an inverse when your determinant is 0. Anyway, for part A, you can just find the determinant as part of finding the inverse. That's fine. Just build that math right in. You're going to get your 16 and your 15. I don't mind you doing that math. That's not too much. Then the 8 and the 2 swap because we're instead of AD, we need DA, right? Then the B and the C, they don't move, but they change their sign. So 3 goes to negative 3, 5 goes to negative 5. Anyway, 16 minus 15 is obviously 1, and 1 over 1 is 1. So if we multiply this matrix, we're going to get that matrix back, and so that is the inverse of A. If this here matrix were called A, then this is the inverse of A. Moving on from that. For part B, you go to find your determinant, and you very quickly get 96 minus 96, and you realize that that means you have a determinant of 0, which means this matrix is non-invertible. So we're done with this one. And for 12C, you're going to get negative 80 minus negative 76. So that's a determinant of negative 4. We modify our matrix, meaning the negative 4 comes up and the 20 goes down, and the other two entries change their sign. So the negative 4 goes to positive 4, the 19 goes to negative 19. Now you distribute the 1/4, and you get positive 1, negative 1, positive 19 over 4, and negative 5. And so that is the inverse there. So there's 3 inverses. You should definitely be able to do inverses of 2 by 2s without too much trouble. Next, we come to 13. 13 is pretty simple too, because we talked about this a bunch for sure. We said that anytime you want to convert a system of equations into a matrix equation, you're just going to want to grab your coefficients. So the 2, the negative 5, and the 1, and that's how you get the first row of your coefficient matrix. It's those coefficients. Then you've got 8 and, there is no y, but there's a 3, so I guess it should be 8, 0, 3. There's your next batch of coefficients. Then you've got the 6 and the 3 and the negative 2, so that's where I'm getting 6 and 3 and negative 2. That's it. You write a big 3 by 3 matrix that contains all the coefficients of all 3 equations. Then I explained that since matrix multiplication is done by multiplying a row by a column, you know that you need to take the actual variables now and plop them into a matrix that's just one big column. So it's 3 by 1, x, y, z as a column. Then you know that when you actually do all this multiplication, over here the entry you'd get is the negative 5. And in the middle the entry you'd get is the 17. And on the bottom the entry you would get, of course, is that 6. But that's it. This is literally all you had to do for this problem, was rewrite it. If somebody is feeling intrepid, then they could enter this into their calculator and see if it actually gives something. It'll give something, but I bet it's monstrously ugly, because I'm sure I didn't put any effort into making it not be monstrously ugly. And that's why I'm telling you not to solve it. I'm telling you just set it up for practice. Then we get to 14. 14 has a secret twist, of course. Those of you who pay attention in class will already know what that twist is. Those of you who won't pay attention in class, or who don't, or who can't, or who should, but don't, you know who you are. You won't know the secret, so I'll make you follow along with me while everyone else just fast forwards. Alright, so let's do this. If I write this thing as a matrix equation, I would go -8, I'd go -6, I'd go 2, I'd go 4. I would make a matrix containing my variables in a column, so x, y. Then I would set my answers into a column, so 8, -2. Then I would pretend that this was a matrix called A, and this was a matrix called B, this was a matrix called X, and I would say that X is going to be the inverse of A times B. So I need the inverse of matrix A. So to find it, I'll go 1 over -32 minus, wait a minute, what? Okay, 16. So 32 minus -32, which is plus 30, and then, rats. Geez. Oh, no. So clearly, since this matrix is non-invertible, this system must have no solution. Now, is that obvious? Times 4. Yeah, that's obvious. All right, so we said you couldn't solve this. Those of you who paid attention in class already knew that. So those of you who paid attention in class got rid of this and replaced it with the thing I told you to replace it with, right? So if you're desperate for another practice problem, period 1, we already did this, so you guys are fine. But if you want to use this, this will work. This is 2x, take away 5, y equals 7. And -2x plus 4y equals -6. That is a system that actually has a solution. So wouldn't be a bad idea to do this by hand. So converting this to a matrix equation, you'd be looking at 2, -5, -2, 4, xy, 7, -6. So that means the matrix xy is going to equal the inverse of this. So 1 over 8 minus 10 times the modified matrix for 2, +5, +2 times the matrix 7, -6. If I lost you somehow, what am I doing? I'm doing what I was going to do before. If this is A, B, if this is A, X, B is how I usually do this, then matrix X is going to be what? The inverse of A times B. So that's what I'm doing. What you see me doing here is I'm finding the inverse of matrix A. And once I have it, I'll multiply it by matrix B, and that'll give me the X matrix. So how am I doing? Where's my face? Here? Okay, don't go into that region, Mr. F. Stay out of there. So what's happening? The matrix XY must be equal to, this is -2, so distributing -2, we get a matrix with a bunch of negatives in it. -2, -5, halves, -1, -1, and you're multiplying that by the matrix 7, -6. So I'm going to go row by column, then I'm going to go row by column. And that's going to give me my answer matrix. So that means the matrix XY is going to have an X value of -14 plus 30 over 2, so 15. Yeah, plus 15. So that's just going to be a 1. Then in the other position, we're going to go negative 1 times 7, so negative 7 plus 6, which is just negative 1. And so that's it. That's the same thing I got when I did this problem in period 1. So we can now say that x is 1 and y is negative 1. So we have solved the original algebra. Well, not you. You're terrible. Get out of here. We have solved the original algebraic system using matrices, which is what I'll expect you to do on the quiz. Yes, I want work. This is what that work should look like. Okay, cool. Next. Find the area of the triangle whose vertices are da 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 da. Okay, sure. We had a formula for this. It's in your packet. We said you should take the coordinates of A, A1, A2, take the coordinates of B, B1, B2, take the coordinates of C, C1, C2, and then you just want 1/2 of the determinant of this matrix that they define. Oh wait, I thought there was a rule that said you can't find the determinant of a non-square matrix. And also I left a big batch of honking room over here. Oh right, because we said after plugging in the vertices you also have to fill in this third column with 1s. Now this rule will work just fine. You can find the area of this triangle by finding the determinant of this here 3x3 matrix. And you've got 2 handy-dandy methods for doing this at your disposal. You've got reduction by minors, or the method of Saris, that weird diagonal method. So let's do this. I want 1/2 times the determinant of -2, 3, 1. 4, 9, 1, 8, 5, 1, which means I want 1/2 times, what method do I want to use? I don't know. I just don't know. How's about reduction by minors? So I'm going to go across row 1 because I don't see any real appreciable difference. So -2 times 9151 plus minus plus. So now it's -3, 4181 plus 1, 4985. Alright, so I don't know, bring down the 1/2. The 1/2 will wait patiently while we calculate this thing. So what do we got going on in here? -2 times 9 minus 5, which is 4, minus 3. 4 minus 8, which is -4, plus 1. 20 minus 72, okay, that's a rough one. -52? Seems fine. 1/2, -8, plus 12, minus 52, so that's +4 minus 52. So that's 1/2, -48. And now seems as good a time as any to remind you that obviously if we're finding area, we really just want the absolute value of this number. So half of 48 is 24. And these would be square units. I hope that's right. That's probably right. Moving on. Finally, it's time for Chand. I'm thirsty. How old's this water? Not bad. Okay. It says Chand has a whole mess of coins in his pocket. 18 in all. But only dimes, nickels, and quarters. No pennies. No half dollars. Anyway, he He knows that they're all worth $2.40. That's good because that's exactly how much he owes his friend Ichi. There are mostly dimes. In fact, there are 2 more dimes than the total number of the other 2 coins combined. Find how many of each coin Chand has by writing a system of equations, converting that thing, Alright, one thing I did not tell you to do is write a let statement. I would like you to write a let statement. Dimes, nickels, quarters. D seems like a good variable. D is going to be number of dimes. Pretty obviously. Nickels. Number of nickels. Again, if you're anticipating not exactly knowing how to define your variables, this is going to be a spot. I mean, you read. What does it say? Right here. It says, find how many of each coin Chand has. That's the definition of your variables. You want to know how many of each coin. So how many dimes? That's going to be D, number of dimes, right? If there was a different question, if I wrote a question about hippopotamuses, which I do believe is the correct plural of hippopotamus, I don't know, badgers and whales. I don't know. There could be a question about all these animals getting on an elevator, and so they need to know how much they all weigh, because it sure would be a shame if they weigh too much for the elevator and the elevator came crashing down. Then maybe H is not the number of hippopotamuses, but the weight of a hippopotamus, right? It's not always going to be the number of. Sometimes it'll be the cost of. I've definitely written a problem before about French fries, sodas, and tacos. Sure. But one friend ordered 2 orders of French fries and 3 sodas. That doesn't make a hell of a lot of sense, does it? And 5 tacos. I don't know. That's somebody's order, and it came to $22.48. Then suddenly now, F is not the number of French fries. It's the cost for 1 order of French fries. So don't get sucked into thinking that the variable is always just going to be the number of, the number of, the number of. Sometimes it's the weight of 1 hippopotamus. Sometimes it's the cost for 1 order of French fries. I've said my piece. Moving on. Sorry for the grisly scene where the hippopotamus, the badger, and the whale plummeted to their death at the bottom of an elevator shaft. That was uncalled for. So anyway, where are we? We're defining quarters as number of quarters. Okay, great. A lot of the time, but not always, your system is going to just boil down to having one equation that basically just counts the total number of things, and that's definitely this one. There's 18 coins, so that means the number of dimes plus the number of nickels plus the number of quarters equals 18. Okay, then often there's another equation that counts the total value of all the things. That's this one, $2.40, right? What's a dime worth? Well, a dime's worth 10 cents. So is that 0.1? Or can that be 10? It can be 10, of course, if we redefine everything to cents. So instead of $2.40, just make it 240 cents. Then your coefficients can be whole numbers if you prefer. There's no reason not to do 0.1, 0.05, and 0.25 because you're doing it in your calculator anyway. But if you want cleaner values, you can definitely have them. You can go 5N, 25Q. But just remember, that doesn't equal $2.40. That equals 240 cents. So lose the decimal here. If you didn't use the decimal here, then you gotta lose it here. Right here. Alright, and then finally, the third equation is often kind of the trickier one. It might not fit this form, and by the way, it has to fit this form of going D, N's, Q's, equal signs, numbers. It has to look exactly like that. But the information that we were given about this is that there are mostly dimes. There are 2 more dimes than the total number of the other 2 coins combined. That's kind of like a miscellaneous equation is sort of how I described it. And this first one is total number. The second equation is total value. And then this third equation is miscellaneous, some random fact about the variables. Now in this problem, what is it? There's a mess of dimes and there's a mess of the other coins, nickels and quarters. They're combined and they are not equal. If these two things sat down together on a seesaw, who'd be the heavier thing? Well, it says there's two more dimes, so I guess my seesaw would be like this, where the dimes are heavier. I'm drawing this silly thing because your natural inclination is going to go, two more dimes than the total. I guess I better add 2 to the dimes. Well, you better not do that, because didn't I just tell you that dimes is already the thing that's bigger? If you add 2 more, then you're adding more to the side that's already heavy. If there's 2 more dimes and you're trying to balance this equation, you better add 2 to this side. That's what's going to bring us back to a balance, right? And that's sort of counterintuitive. Maybe it's totally intuitive. Hopefully it's totally intuitive for you that obviously if there's more dimes, then you better add 2 to the nickels and quarters if you're trying to make them equal. But too many people read this and they try to do a literal reading of it. They go, 2 more dimes, 2 plus D, then the total, okay, equals the total, N plus Q. That's going to be dead wrong. You're going to get the wrong answer, right? You need to take a step back from it for a minute and realize that what's happening is you're comparing dimes to nickels and quarters. Are they equal? No, they're not equal. There's a 2 involved. Which side should the 2 go on? The 2 should get added to the thing that's currently too small. And if there's more dimes, then dimes is already big. So add the 2 over here. Okay, again, I'm probably over-explaining, but if I helped even one student, then it was all worth it. Right, class? Isn't that what they say? Okay, I forgot. Now, guess what? I still can't plug this in because I'm supposed to have an equation where it goes dimes, nickels, quarters equals number. So the nickels and quarters that are over here, they need to get dragged kicking and screaming to the other side. So really my equation should be D minus N minus Q equals the number 2. We did it. We wrote an equation. So that was great and all. It's really great how we mastered part A of the problem. But now we have to convert that to a system of matrix equations. That's part B. Then we have to solve that. That's part C. There's 3 different things you're supposed to do. That's part A. Part B now is turn this into a matrix equation. That's supposed to be easy. We just pull out the coefficients, which are 1, 1, 1, 10, 5, 25, and 1, negative 1, negative 1. And my variables are D and Q. And then my answer matrix is 18, 2, 40, and 2. Okay, great. So now, finally, I can bring up my calculator, which I'm sure Kabir has already put his order in for. Right, Kabir? Okay. Where are you, calculator? Yeah, okay, this works. So by now you should know what you're doing mostly. We want to enter a matrix, so hit second matrix. You want to edit a matrix, so go over to edit, and let's edit matrix A, and its dimension should be 3 by 3. Okay, great. My entries are 1, enter, 1, enter, 1, enter. My second row is 10, 5, 25. 10, enter, 5, enter, 25, enter. And then my last one is 1, enter, negative 1, enter, negative 1, enter. There, this is the right matrix for matrix A. Now I will go second matrix. To get back in, this time I want to edit a different matrix, probably B, and his dimensions are only 3 by 1, and I want that one to be the answer matrix, the 18, 240, and 2. So I'll enter 18, 240, and 2. Enter. Alright, I will now quit. Back to the home screen. I will then go matrix, and I'll choose matrix A. While still on names, I'll choose matrix A. That'll dump A to my home screen. and I can then press inverse, boop, and then I can multiply by matrix B. You can hit the multiplication sign. You don't have to. As long as they're next to each other, it understands to multiply. Anyway, I'll now mash enter, boop, and I'll get 1035, which is the correct answer. So I will now record that answer. So you'll tell me the answer for part C is that DNQ, the matrix, is equal to 1035. And when you take this quiz tomorrow and you find that you have tons of extra time left over because you studied so hard and the quiz was slight, you could turn this into a sentence if you wanted. You could say, Chand has 10 dimes. Just, obviously make a sentence out of it. Chand has 10 dimes, 3 nickels, and 5 quarters. Or, I guess, Ichi does really. Ha ha ha, get it? Because remember he owed Ichi. Get it? Okay. Anyway, I don't care, moving on. You may turn off the video at this point. Or we could talk about the video that you were supposed to have watched that talked about a different way to solve this equation using what's called reduced row echelon form. So what was our matrix from 1 second ago? We had a 1, 1, 1. Then dimes, nickels, quarters, so 10, 5, 25. Then 1, negative 1, negative 1. Yeah, that seems right. Now I told you to just do a 3 by 3, but what you can also do is kind of like when we did the area of a triangle, right? I'm behind the calculator. I know I'm behind the calculator. But when we did the triangle, didn't we do, we did the vertices. So it was like A, B, C, D, E, F. But then we appended a whole column of 1s, 1, 1, 1, right? Well, we could do a similar thing here. Instead of making a whole separate variable column, instead of making a whole separate answer column, take the values of all these. Chand had how many coins? 18 coins? I really don't remember. Feels like 18. Yeah, 18, 240, and 2. Put that right in the same matrix with it. 18, 240, and 2. I think they literally do draw a line here sometimes to kind of indicate that, yeah, sure, this is one big matrix, but it's kind of different. It represents different stuff. But what you can do now is put your matrix into something called reduced row echelon form. And reduced row echelon form is where you basically turn the 3 by 3 part into an identity matrix. 1, 1, 1, 0, 0, 0, 0, 0, 0. And as you modify the rows and columns of the matrix to get this thing into this form, these other numbers over here change into the solution of the system, which for us was 10, 5, 3, 10, 3, 5. But if you're able to turn this matrix into this matrix, then this column will magically become 10, 5, 3. And that'll be the answer. I don't know if anyone cares about this at all. I'm not going to explain how to do it by hand, probably, but it's kind of fun. Again, if you're into this, take linear algebra. But I mention this only because I know some people people who are good people and watch the video, they did it the way the video said to. So we'd edit our matrix, our 3 by 3. Well, it would have to be 3 by 4. That gives me the next row. I'll enter now the 18, 240, and 2. You have to hit enter. And I'll quit to the home screen. I'll go back in, and under matrix, under math, where you can find determinant and stuff, way the heck down here, is RREF. What's ref? Row echelon form? We definitely need to have reduced row echelon form. So choose option B, and then go back into the matrix and choose A. And basically this is a command